Alrighty, we are being asked to predict the direction in which a system will shift to reach equilibrium for each of the following cases. This is the synthesis of ammonia, and the equilibrium constant is given to us. It has a value of 6.0 times 10 to the negative 2. So I'm going to go ahead and label that. Equilibrium constant has the symbol K, and since they didn't specify, we're going to assume that we're talking about Kc. Okay, so our Kc is equal to 6.0 times 10 to the negative 2. We also need a balanced chemical equation. Synthesis of ammonia means we're making ammonia that is produced from nitrogen and hydrogen reacting together to make NH3. Also have to balance the equation. We're going to need 2 ammonias and 3 hydrogens. Okay, and so in part 8, we are given initial concentrations for each one of our chemical species. And I know that these are initial values because of this 0 here. That means initial. At time 0, these are our molarities. And so I don't know initially if this is an equilibrium ratio of products to reactants. And so when I'm given initial values, I do need to calculate Q. And the value of Q, and I compare it to K, that's going to tell me the direction in which the system is going to proceed. Okay, so we're going to write out our QC expression. Okay, we know QC is products over reactants, coefficients are exponents, and C means concentrations, so we're using square brackets. And now for our Q expression, we're going to plug in all the initial values given to me in this question. And then when I calculate this, I get 1.25 times 10 to the 7th power. Now, to determine if this is at equilibrium, I compare K to Q. So the Kc given to me in the problem was 6.0 times 10 to the negative 2. The Qc that I just calculated is 1.25 times 10 to the 7th power. And so that means Kc is less than Qc. So because, first of all, they're not equal to one another, this is not a system that is at equilibrium. So we are not at equilibrium. So the system is going to proceed in a certain direction in order to establish equilibrium, in order to make Q equal to K. So right now I can see here that Q is too big. So the value of Q needs to decrease. And so this system is going to favor making more reactants so that the value of Q does decrease and eventually equal K. Therefore, the reaction is going to proceed in the reverse direction, or you could also say left, in order to establish equilibrium.